So now we have the symbols generated and ready for transmission. But normally we do not transmit the symbols directly. We have to do this path shaping step so that to make the signal robust against different channel or hardware impairments. So to do that, we give our signal a shape based on different filters. In communication, normally we have different options of filters like Gaussian filters, rest Gaussian filters, rectangular filters, and so many others. So in this lab, we will focus on the rectangular filter, and we will see other filters in the upcoming labs. So to implement the rectangular filter, we can use the RipMat function from the MATLAB. So to do that, we first oversample. First of all, like to implement the filter, you need to oversample your signal and then filter it with the filter shape that you have chosen. So the simplest way of implementing a rectangular filter is to use this function, which is takes the modulated symbols at the input and the oversampling ratio as another input that we have specified before. So this is similar to doing this is similar to oversampling out the symbols, each symbol, and then convolve it with a rectangular filter. So what we will get out of this is going to be a matrix of oversampled symbols that we can see right away. Let me plot it. I'll close this one. So this is what we are getting is 16 by 1000 samples, whereby each symbol has been repeated 16 times, so for all 1000 symbols. So after getting this, we have to reshape this matrix into a vector, which will give us the signal that that is now ready for the transmission. To do that, we will use the shape function and we will enter its related parameters here. After this step, we will have the signal that we can transmit. So now let's go ahead and see this signal in time and in frequency domain. So in time domain, we will plot, because this is a complex signal now, it is real and imaginary part, so we will plot its real and imaginary part separately. So let me do that. So as you can see, this is the signal that we have just generated. It is rectangular shaped. That means here we have sequence of the similar symbols. Like if this is 2 and this is 1 symbol, so here we have like 7 symbols. And for the imaginary part, the same thing. You can have different symbols, with rectangular shape. So this is what we expected and we got it, so it is fine. Now let's see the same thing in the frequency domain. So in the frequency domain, we will be plotting the power spectrum of the generated signal, which we normally plot by using P-Welch function. So it takes the signal that we have generated and oversampling ratio, and we make it centered, so the spectrum will be centered at the carrier frequency, which is 0 in this case, because we are doing a baseband. We are in the baseband mode now. So, and the other parameters, we are using the default parameters. So for those who are interested, they can go into MATLAB and see how to use this P-Welch and which kind of options you have here in the parameter that it can take. So we plot and it gives out the output as the frequency components and their associated power. So in the plotting, in the x-axis we'll have the frequencies, and in the y-axis we will have in dB the power that you obtained from here, normalized by the maximum power, which will make the maximum power for spectrum 0 dB. So again I will plot this and see. So just continue. So this is what we are getting. As I said, maximum power is 0 dB and it's centered at 0 frequency because we are working in the baseband. And the shape also is what we can expect because we used the rectangular filter in time domain. That means we will have the corresponding sinc function in the frequency domain. So in the transmission part, this is done. I think we can now go ahead and generate the channel, the AWGN channel, in the next step.